Hi everyone, Will from Foligram here. In this tutorial we are going to look at how to prepare a typical Rhino model for viewing in mixed reality on a mobile phone or a headset using Foligram. So typically Rhino models contain many individual objects. They might contain some trimmed geometry like these pipes that we've modeled up here, some extrusions, bunch of curves, things like that. And all of that will render fine on your PC just because most people who are modeling with Rhino have a decent sort of graphics card, and that computer is capable of drawing lots and lots of geometry. Now, how Foligram works is it will take all of this geometry in your Rhino model, and for each individual object, it'll mesh it using Rhino's default mesh settings, and then it'll send that mesh geometry over the internet to your mobile phone or HoloLens or other mixed reality headset, where it will be rendered on device. And a typical mobile phone isn't as good at rendering lots of geometry as your laptop computer, and so this can lead to some performance issues. For the best possible experience in mixed reality, you want everything to run nice and quickly, and so there are a few things that you can do to prepare a model for viewing in augmented reality. And these are all pretty simple things like do's and don'ts and a couple of tricks just to improve performance. So the first one that we'll go through is joining in many individual objects together. So here we've got a brick wall. It's a bunch of individual bricks which are actually already meshes in this model. And each brick is rotated a little bit to create a pattern. They're all individual objects because when we were modeling this, that was convenient. We wanted to sort of move bricks around or delete some or whatever. When you stream this model to Foligram, or if you upload it to the cloud, what's going to happen is each one of these bricks will be an individual object, which will all be rendered separately on the device using something called a draw call for each brick. And that's less efficient than joining all of these meshes into a single object and rendering it all at once. So where possible, if you've got a bunch of objects which share the same material and where you don't need to edit them individually in augmented reality, you should join those objects into one object. So for this brick wall, if we were just going to visualize this model, we just wanted to look at it, we didn't want to edit it, we could take all of these bricks and join them together using the join command to create one big mesh. That is going to render much more efficiently in AR on a mobile phone than those 2,500 individual bricks. Now, if you instead were wanting to use Foligram to construct this brick wall, and in that case maybe you would want to view these courses of bricks one at a time. So I've actually already got them organized into layers here, where each layer contains the individual bricks in that course. Depending on what else is in your model, Foligram might handle that just completely fine, since this is only maybe 100 bricks or so for each layer, render fine. But if you are running into performance issues, you could also join these individual layers of bricks into a single object one at a time, and that's going to render more efficiently. So that's the first rule of thumb. Where you have many, like thousands of individual objects, just join them together if you can before you stream that model over to the HoloLens or your mobile phone. All right, the next thing that we're going to cover is pipes and just generally how NURBS objects get meshed. So typically when you're modeling things like, balustrades, handrails, 3D curves, things like that in Rhino, you might use the pipe command to create the 3D geometry around those curves. Here we've got a kind of a bunch of drainage pipes modeled. They're all NURBS geometry, so you can edit them nice and easily. And we could send this over to the headset or mobile phone, but we might find that this actually creates quite a few polygons in a very heavy model that takes a long time to render. So we can check this by selecting our model and just typing mesh, hitting OK. It's going to go mesh everything. I'm going to say cell last to have a look at that mesh. And you can see that for a lot of this pipe work, we are generating quite a few very small triangular faces. Now, depending on what we're doing in mixed reality with this model, again, if we just want to approximately visualize it and we don't care too much about millimeter precision of where this model is located, you might not actually need this many mesh faces to describe these things like the junctions in the pipes. And so we could reduce the number of mesh faces before we send this over to our device, just so everything runs a bit faster. So if you have a model with lots and lots of piped geometry, whether it's plumbing or balustrades or whatever, especially if you have thousands of pipes or those pipes are all curving around a lot, we would recommend using the mesh command, turning down the default settings so you have fewer polygons, and just trying to create as sort of a low poly mesh as possible. This is, again, 117 mesh objects, so we would use the join command to join those into one mesh object. And just visually looking at it, we can see there's not too many mesh faces on this object, but we can also use the what command, and that will tell us how many vertices and faces we have just in this piece of geometry that we have selected. As a good rule of thumb, you want to keep your model to a sort of maximum 100,000 polygons, so faces for viewing on mobile phones or the HoloLens, though you should be able to go up to 1 million and have everything still run kind of okay. But fewer is better as a good rule of thumb. Okay, the next typical issue that we might find in streaming typical Rhino models to our mixed reality device and leading to things like slow frame rates or poor performance is trimmed surfaces. So a lot of the time when you're modeling in Rhino, you might have something like a plane. Let's get some points to just make this plane not flat. And then we might have something like, I spelled circle wrong there, how embarrassing. Circle, and we might project that onto the plane. Okay, there we go. We got a circle, and then we might trim that shape out from our surface here. So this is a pretty typical bit of geometry in Rhino where you have a NURB surface that has been trimmed with some other shape. This is performant to render in Rhino, but when you mesh it, again, if we use the mesh command with default settings, you'll often find that in order to, depending on how much curvature we have in this surface, this plane that I modeled doesn't actually have that much curvature, you'll occasionally find that this is creating very, very large numbers of mesh faces in order to render or accurately model these trimmed shapes. If you've got lots of trimmed geometry in your model, we would recommend, again, using the lowest possible meshing parameters and streaming the mesh geometry, hiding your NURBS geometry before you use Fologram to make sure that the NURBS surfaces with their default meshing is not being sent over, and instead you are controlling exactly the geometry that's being sent over by meshing it first. Okay, so things to avoid: pipes, trimmed surfaces, be sure to mesh those first. The other thing is if you have curves in your model and you are typically piping them just so that you give those curves some volume, you can instead use the Rhino curve piping tool to create mesh pipes from those curve objects. So if you have a lot of curves in your model, I'm going to go cell curve just to grab all the curves in this model and pull them over here. Let's say that Fologram will render these curves fine. You can just stream the curve objects. That's no problem at all. But if you wanted to instead give all of these curves thickness for some reason, maybe you were actually trying to model a bunch of pipes and accurately locate those pipes, you didn't just want center lines, what we can do is we can select all of these curves and we can go into the properties panel, and then I'm in Rhino 8 here, and then click on curve piping, and we can turn on curve piping with low accuracy to create mesh pipes from all of this geometry. So let's go ahead and do that. We'll select all these curves, turn it on. We're going to make the radius something pretty small. Let's make it 5, let's say. Segments, we'll have as few segments as possible. So if we make the segments 4, this is just going to make rectangular extrusions along our curve profiles. And I'm going to make the cap type flat. So the whole idea here is we're trying to create some volume around these curves using as few mesh faces as possible. If we zoom in, I made those pipes really, really small, but there's that geometry there. Now, this is just a preview of the geometry. It's not actually showing us, it's not creating these mesh faces yet. It's just drawing them to the screen for us as a preview. For this geometry to be sent to Foligram, and turn that accuracy down. For this geometry to be sent to Foligram, we first need to extract it. So for that, we can use the extract piped curve command, and that will take all of those meshes, which we just previewed, and turn them into actual objects. Once again, we can grab all of those meshes that we just created, and we can try and join those together. I've created a bunch of curves, so I'm just going to undo that. There we go, we got our meshes, and we'll join those together before sending those off to the HoloLens. So we now have one very, very efficient mesh object, which gives those curves thickness if we need it. Okay, we've covered trim surfaces, we've covered joining objects, we've covered pipes, we've covered mesh pipes. The next thing to think about when we're streaming objects to Foligram is Foligram has something called default curve resolution. So if you stream a curve to Foligram like this, rather than, like what Foligram actually does is it discretizes this curve. So it takes this smooth Bezier spline and it turns it into a polyline in order to efficiently render that on your mixed reality device. So a bit like how Foligram will take smooth NURBS surfaces and turn them into faceted meshes for efficient rendering, we'll do the same thing with curves. We're going to facet those curves into segments, and we'll do that with some default curve simplification parameters. If those default parameters are creating facets which are too large for your application, so I'm going to use the rebuild curve tool here, and if we set this to degree 1, this is going to give you effectively a preview of what a faceted version of that curve might look like. Again, the actual number of facets that get created depend on the scale of your curve and the detail of the curve and things like that in Foligram, but this just indicates approximately what's going on. If this is too low resolution for you, what you can do is you can take that curve, use the rebuild command in Rhino, and just set a higher point count. So let's say we want this curve to appear very smooth in Foligram. If we set this to a division of say 50, keep the degree 1 again, that's then going to go create a polyline with 50 segments along it. Or actually, sorry, it's 50 control points, so I guess 49 segments. And this lets us create the kind of the appearance of a smooth curve, even though it's actually made up of these kind of straight line segments. So if you're running into issues, you're wanting to draw lots and lots of very, very smooth curves with Foligram, just make sure that you rebuild them as polylines first before you stream those over. Okay, the last thing that we want to be aware of before streaming models to Foligram is material texture size. So again, when you're assigning materials to objects in Rhino, you may or may not actually be thinking about the size of the image textures that you put on those materials, because for the most part, desktop PCs with good graphics cards will be able to render most texture images okay, unless you're using astronomically large ones. That's not necessarily the case for Foligram. So there's a couple of tips here. If you're using Rhino materials with lots of different image textures, whether that's for your the color of your material or for bump maps or things like that, just go and check the size of those images, and as a general rule, try and keep them to under 1024 by 1024 pixels. Foligram uses a default texture size, and we can see that default max texture size in using the XR properties command in Foligram. The default is 1024 by 1024 pixels. So any textures which are larger than that will be resized down to that maximum size. If you need to work with very, very high resolution detailed image textures, you can increase this max texture size, but just keep in mind that that can lead to performance issues if you're working with really, really large 4K or 8K textures. Make sure your device is able to render those, especially if you're using multiple different texture images. All right, so that takes us through model prep. Joining objects, meshing pipes, using the curve piping tool, working with trimmed surfaces, rebuilding curves, and also ticking off material texture sizes.